As long as I can remember, I've enjoyed mechanical devices, especially motors. Several years ago, I heard about solenoid motors and decided to make one that could be used in my physics classes to study how they work. It involves a stand that can have several parts attached to it and then adjusted. The bottom piece is a 12-volt solenoid mounted vertically. In the middle is the crankshaft, connecting rod, and piston. On the top is a micro switch to trigger the solenoid at the right time. The CD acts as a minimal flywheel. This year, my son and I built 2 solenoid motors that are kits from Temu. The design is fairly typical, but it uses a photo interrupter instead of a micro switch. This led me to try to design a solenoid motor using a photo interrupter and 3D printed parts designed with OpenSCAD. In version 1, the 3D printed flywheel was inadequate, which is noted by the change in speed as you change the piston's orientation. To make the interrupter circuit, I started with a circuit to control motors with an Arduino by Adam Meyer. A link to his work is in the description. I modified the circuit to take the 5-volt signal from an interrupter instead of from an Arduino. The TIP 120 transistor that Adam uses handles the high power demands of motors and solenoids, so the motor in Adam's circuit is replaced with a solenoid. The interrupter is a 5-volt unit from Amazon that has 3 connections, 5 volts, ground, and the signal. The signal is 5 volts when the interrupter is blocked and 0 volts when it is unblocked. I etched the circuit onto a copper-clad board with a small CNC machine. The G-code for the etching and drilling are linked in the description. Here's the finished circuit board. And here's the backside with a parts placement guide. Version 2 of the 3D printed solenoid motor uses 2020 extrusion parts as well as specific parts for this design. All the parts are designed in OpenSCAD and available in Thingiverse. There's a link to the Thingiverse files in the description. The extrusion parts are connected with M4x8, M4x10, and M4x12 bolts, with M4 T-bolts. Using 2020 extrusion parts makes the motor very adjustable.